I'm going to talk a little bit about El Nino, La Niña, and why they matter to the southwest U.S. I know most of you are from Colorado and California, so I tried to structure it that way, but I'll also mention a few other places as well. So the questions that I was told you are the most interested in are, what is an El Nino and its cousin La Niña? How does it affect weather patterns in Colorado and California? Was this year unusual in terms of El Nino activity, and what can we expect for the next year? So I'm going to try and touch on all of those points. And I first wanted to talk about the trade winds topics. And I apologize if any of this is repeated. I'm not sure exactly what you covered in the last couple of weeks, so if it's reviewed, that's okay. But I had a map up here. So the Pacific Ocean is where El Nino primarily takes place, and it's controlled by the trade winds. So as a consequence of the Earth's rotation, you get prevailing winds in the tropics that blow from the east to the west. And you can see that here, and they're called the trade winds, because they used to be very important for trade, people crossing the oceans and all of that. So normally you get east to west winds. And that has consequences for the average temperature in the Pacific Ocean. So along the equator, you get these winds that are blowing from the east, and they're pushing all the water into the west. So if you can imagine if there was no wind at all, and the ocean was just sitting there, not doing anything, you might have a uniform layer that was all the same temperature. But because you have these winds, they take all the water and they build it up into this warm pool. So this plot is a plot of the temperature at the surface of the ocean, or sea surface temperature. So that's what I mean if I say that at some point. And blue is cooler, red is warmer colors. And so typically what you get in the Pacific is temperatures in this warm pool that are about, what is the difference there? About maybe 5 degrees warmer than the temperatures in the east. And that's, people like to refer to that as the cold tongue, because it kind of looks like a tongue of colder water. And so that's normal for, this is for the month of December, but you can imagine that the temperature changes a bit with the seasons, of course, but those are the typical conditions that you see. And that drives a circulation in the atmosphere. It's called the Walker circulation. So what happens, here's a three-dimensional view of the Pacific. So here we have Australia, and then the US is up in the corner there. Can't reach it because I'm short. But what happens when the air sits over the warm pool here is it heats up, and then it becomes less dense, so it wants to rise. And as it rises, it becomes less able to hold its moisture, and so it starts to rain. So you get a lot of tropical convective thunderstorms in the western Pacific. And again, you have this air blowing along the surface from east to west. So what happens when this moist air gets up to the top of the troposphere is it has nowhere to go except back to the east. So it goes back east, and then it cools off as it goes, and then by the time it gets to the eastern Pacific, it becomes more dense and it sinks again. So you get this loop of air going across the Pacific Ocean, called the Walker circulation. And I have like URLs in various places that tell you more about it.
Does that mean the winds change then? So you get then, instead of the east to the west, would you get more of a west to east wind then?
Right,
Okay.
so yeah, and this is at the surface, the trade winds blow from the east to the west. And then once you get up here, so this would be like maybe at the altitude where planes fly, so like 30,000 feet or so, you get the air going the other way again. Yeah, so it matters like what level you are. So does that make sense to everybody? Okay. Cool. All right, so that's generally what's going on in the Pacific Ocean. And then I have a different schematic here of also normal conditions, but the point I want to make here is that El Nino and La Nina are basically a disruption of the normal Pacific Ocean climate. So here we have, again, Australia, South America, our western warm pool with the convective loop, so our Walker circulation going on above it. And if you look deeper below the surface of the ocean, then you see what's called the thermocline. So I don't know if you talked about this, but you have warmer water in a surface layer, and then the temperature changes really fast as you go down, and that's this thermocline. So that just means temperature changing fast. and you have cold water below that. So this is another way of visualizing the warm water being pushed to the west. And then during an El Nino event, the trade winds at the surface, again, get weaker. So now you're not pushing the air over to the west as strongly, and you get warm water sloshing over into the eastern Pacific. So if you look at what the Thermocline's doing, and you have warm water going in a layer that goes down to maybe 100 meters in the eastern Pacific now. And that's called El Nino because it was named by Peruvian fishermen, because this tends to happen in wintertime. So it tends to happen around Christmas. So that the Niño refers to Christ child. So that's where it got its name. And then La Niña is just the opposite of El Nino. So instead of the trade winds being weaker than normal, now they're stronger. So you shove your warm water over even further, and you get colder conditions in the eastern Pacific off the coast of South America, and warmer water near Australia. And the whole thing, the cycle between El Nino and La Niña, is called the El Nino Southern Oscillation, or ENSO for short. If I say that, that's what I mean. So trying not to be jargony in this talk, but sometimes it slips in. But next I wanted to show you how NOAA and scientists generally define when you are in an El Nino or La Niña state. So I had a picture of where this region is in the Central Pacific. But yeah, so scientists have defined these different regions of the Pacific and given them names because they tend to be the places where the physics that's relevant for El Nino takes place. And one of those is Niño 3.4, which is named because it's between Niño 3 and Niño 4. It's very imaginative. But it's basically this region right here. So it's like 50 degrees of longitude wide, and it's right smack in the middle of the Pacific.
On the equator.
Yeah, on the equator. It goes from like 5 south to 5 north. So about here to here, this region. Okay, so that's, and then there's other ones, so this is Niño 3, that's Niño 4. But the middle of the Pacific is where people like to think about when they're trying to figure out whether we're in El Nino or La Niña. And if you look at the temperature in that region, and you plot it as a function of time, then it looks something like this. So this is for the period from 1970 to about 2000. And the red colors indicate warmer than normal, and the blue colors indicate cooler than normal. And that's why, like, this isn't the real temperature, this is the anomaly relative to the average over that time period. So what NOAA does in their forecasting is they use the 3-month running mean of this Niño 3.4 sea surface temperature. So they say, all right, what's it been for the past 3 months? Is it more than, I think it's about a half degree above or below the average? And you can find the exact definition on their website. But yeah, this is how they actually figure out whether we're in normal conditions or not. Yeah, there's something called the Toga Tau buoy array, which I have put the URL for in the slides, I hope. It should be on the last page. But it's run by NOAA. It is a network of, how many? Maybe like a few dozen to 100 buoys, and it's all over the Central Pacific. And you can go to their website and you can download the real-time ocean temperatures for, I think it's updated daily, or at least monthly. So you can actually like make a little movie for yourself of what the temperature looks like. You just make a plot.
So if it's cooler, it's El Nino.
Warmer is El Nino.
Oh, warmer.
Yeah.
So top is El Nino, right?
So La Nina, El Nino. Yep. Okay. So that's how we define it. Whether that's a good definition or not, you can debate about, but that's what people use. And next I wanted to talk about how these things actually affect weather in the US. And the way that it works is El Nino and La Niña, they affect the temperatures out in the tropical Pacific here, and that in turn influences the jet stream. So you may have talked about this already, but the jet stream is another consequence of the general circulation of the atmosphere. You get very high winds in the upper atmosphere. So again, this is near the top of the troposphere, about the elevation that aircraft fly. And this is actually why they fly at that altitude, because if you fly along with the jet stream, then you can save a lot on fuel, because there's really strong winds. You can see here they get up to 140 miles per hour or so. And one of the jets is about at 30 north. So 30 north is somewhere around here. And it tends to want to move south in the wintertime and north in the summertime. So it migrates around, but it's generally around those latitudes. And then there's another jet further north that's called the polar jet, and that tends to be hanging out over Canada and Alaska in the northern latitudes. So there's associated that describes them here. But the point is that the weather patterns in the tropical Pacific influence the jet, and then that influences weather in the United States and in other places as well. So that's how that works. But what exactly does it do in the different phases? So this is the best graphic that I could find, and it shows what the El Nino phase of the oscillation does to weather over North America. So this is the typical anomalies that you get from January to March. So this would be during the peak of the El Nino phase. This would be when temperatures in the eastern Pacific are like the warmest that they're going to get for that event. And what that does is it makes a low pressure system form off the coast of Canada. And that, I don't know, did you talk about pressure systems at all? Mm-hmm. Yeah, okay. So then you know that air wants to flow counterclockwise around a low pressure system in the northern hemisphere. And when you have a jet coming this way already, and you have air tending to want to go, this direction, in that region, it makes the jet extend further horizontally than it might otherwise. And it extends all the way over the coast of North America, and it tends to amplify the storms that go along with the jet stream. And what that means for the southern United States is that you're tracking all of this air over the Pacific Ocean, where it's building up a lot of moisture, and you're bringing it over land. So you end up with wetter weather in the southern states. Sorry about that. In the wintertime. And you also end up with cooler temperatures as well. So in the northern states, you get kind of the opposite effect. So now you have warmer temperatures than usual. And why is that? Well, normally, if you don't extend the jet stream this way, it wants to bend up a little more and take a path that's more like this. So ordinarily, you would get a lot of air coming down from the north and bringing in cooler temperatures into the Pacific Northwest. And if you talked about the 2010 Summer Olympics, or the Winter Olympics, of course, at all, but that was in Vancouver, and they had a whole lot of trouble getting enough snow to run the ski lifts and all of that. And that's because we had an El Nino event going on. Well, I mean, you can't attribute it 100% to El Nino, but those were the prevailing conditions during the winter of 2010. And so you didn't tend to get as many systems coming in from Canada and bringing in all this like freezing Arctic air, and so it tended to be too warm to build up enough snow. So I know it's not technically California or Colorado, but I thought it was interesting.
So are you basically saying that the wetter weather they might have had, but they didn't, ends up farther south? Is that?
Yeah, you could think of it that way, sure. So you would grab your moisture up from this region ordinarily, bring it in over Washington and Oregon, track it down there. And now that you have an El Nino event, the jet stream wants to go further south. So, yeah, I think that's right. So on average, this is the effect that you get on temperature. So that was a schematic before, but this is from real data. So this is a composite of the 10 strongest El Nino winters that we've had in the past 50 years. So from 1957 to 2002 or so. And if you average all those together and you take the difference relative to the average from over the past 30 years, then you end up with an anomaly of about 1 to 3 degrees Celsius in the Pacific Northwest and about 1 to 2 degrees cooler than normal in the Southwest and Southern California. And one interesting thing is that Colorado sits on the boundary between those temperature anomalies because it's partly because of the Rocky Mountains, but the jet stream tends to want to go further south during an El Nino event. And we don't get as reliable an impact of El Nino as you do someplace like Arizona and New Mexico. It's a little bit harder to predict. And I wanted to make that point with real data again. So if you look at a given El Nino event, maybe it'll look like the average, and maybe it won't. And the stronger events tend to look more like the schematic that I showed before, right? So you have your jet stream going, the wrong button. But yeah, you have the jet stream going almost uniformly horizontally in this cartoon. And that looks a lot like what happens during the 1997 to 1998 event. And this was, again, one of the strongest ones that we got. And this is data from a model that has incorporated all the observations from the wind. So you can think of it as observations. And you had the wind in February of 1998 going straight, normally, right? So horizontally across and into northern Mexico and southern US. And the colors are the speed of the wind. Yeah. The colors are the speed and the arrows are the direction, in case you're wondering. And so you had really, really strong speeds of the jet stream. It was going almost like a uniform direction straight over California. And anybody know what happened in Southern California that winter? Sorry? Yeah. Yeah, a lot of rain. And there was really bad flooding in Southern California that winter. So this can be very important if you get a strong event. Then you just get all these storms just swept right straight over Southern California. But just because you're technically in an El Nino doesn't mean that's going to happen, especially not if it's a weaker event like the one in 2006 to 2007. So we had a warmer than normal temperature in the Eastern Pacific because of El Nino, and you got a little bit of this flow that you would expect from El Nino, but not as much. And it reflected a bit up and into the Pacific Northwest. So you had a little bit more variable jet stream, and we didn't have as many flooding events, I don't think. So it wasn't as big an impact. And there's all different types of El Niños. People like to talk about like them being created differently, but the point I want to make here is that just because you're in one phase of ENSO, or El Niño or La Niña, you might not have the same impact. I wish it was simpler, but can't always get what you want, I guess. So this is just an illustration using California data. So if you look at the total flooding and storm damage for the year average from summer to summer, then this is in millions of dollars. So damage above 1,000 here is upwards of $1 billion. This would be like a really bad flooding event. So we have our 1997 event here, yeah. And, oh wait, no, I guess this ends before. Yeah, this is the summer of 1997, so this would have been right before the start of the event that I just told you about. And the higher, larger bars indicate more damage, and the color of the bar indicates what kind of a phase that we were in during that particular year. So blue would be La Niña, and red would be El Nino, and green is neither. So you can see that sometimes there was a lot of damage during a year that wasn't especially special in terms of El Nino activity. So it's not always a cut and dried story. But generally speaking, those are the weather patterns that you get with El Nino. And La Niña is the opposite. So instead of a low pressure sitting over here, instead you have a blocking high. And they call that a blocking high because air flows clockwise around the high pressure system in the northern hemisphere. And that opposes the direction of the jet stream. So you have jet stream and then the high here. So it tends to deflect it a little bit. It makes the direction of the jet stream like much more variable. And it also kind of splits the flow, right? So then you get the polar jet going around here, and you bring in air all the way from Alaska, all the way down over the Pacific Northwest. So you get very cold and wet temperatures, wet conditions during La Niña. And in the southwest, you get dry conditions, because all this moisture is instead going further north. So you end up with very strong droughts in the Southern California and the Southwest. You can see that if you correlate El Nino and precipitation. So hopefully this graph isn't that confusing. It takes a second, but if you look at the colors, the red spots are the places where you get more precipitation during El Nino, and the blue ones are where you get more precipitation during La Niña. So in the wintertime, that's snow sometimes. Summertime, it's mostly rain. But in Colorado, in eastern Colorado in particular, you get much more precipitation during an El Nino in the winter. In the summer, you get more precipitation in the high country during La Niña. And this is the drought that I was talking about in the summertime during an El Nino year. So, oh, and then Boulder is right about here, I think. So yeah, does that make sense? Hopefully? Okay, good. So, as an example, right now we're just coming out of a fairly strong La Niña. And if you look at the mean position of the Pacific jet stream from April to May, then it looks something like this. And so you had the jet dipping down and making this nice trough over Colorado. And for those of you who live here, like the weather was pretty weird. Remember, like I kind of felt like I was in Oregon or something for most of May because it was gray and it was drizzly and rainy. And that was because this trough right here liked to hang out right over Colorado and drive all of this rainy weather. And we don't normally have. So that was probably influenced by the La Niña conditions. And then just to show you how the precipitation changed in the spring as a function of like space in Colorado, you can see it's very different depending on whether you're in the mountains or on the plains. So from February to May, we got about 150% more than normal precipitation. And so the colors here are blue means more precipitation and red means less. And so we got record snowpack in the high country of Colorado, but relatively little rain on the plains. So we got a lot of rain over the Front Range, where you get these troughs, like I was saying, near the mountains. But on the plains, the conditions are more like they are in New Mexico and further south. So we haven't gotten very much rain there. But what does this mean? Oh, this is a bit blurry, so I apologize for that. But most of the water in Colorado comes from snowmelt. So I heard you talk about that earlier in the workshop. And so that means that when you have more snowpack, then you can expect to not have water shortages as much. And if you look at the stream flow forecasts as of April from this year, so this is the forecast for throughout the spring and the summer, then it's looking pretty good for most of the Colorado River Basin. And you've heard about this in more detail than I'm talking right now. But La Niña is good news for that. So stream flow is going to be, according to this, about 130% of normal, so 30% more than you would ordinarily get. So that's good. That's because of these snowpack conditions, which extend over most of the Rockies, at least near Colorado. But once you get further south, then you run into more problems. So you haven't gotten as much rain as usual because of La Niña conditions. So there might be some droughts in summer of 2011. And it looks like that is the case, especially in New Mexico. You guys heard about the fire that's still going on outside of Los Alamos? I looked it up this morning, and it's 3% contained right now. Yeah, it's like huge everywhere. And this is just someone's Flickr page from near the Los Alamos National Lab, where they turn and clear byproducts. So there's been an extreme drought going on in most of New Mexico for the past few months, and that's dried out all of the vegetation that's around there, and it makes it really easy for wildfires to spread. I mean, that happens here in Boulder too. Like, we got a big fire last year. But this particular one is probably has been contributed to by the La Niña that's been going on for the past winter. So I guess New Mexico is probably praying for La Niña to end right now. So these are extreme, sorry, I should explain what these colors mean. So the redder that the state of New Mexico is on this figure, the more extreme the drought has been for the past few months. and is projected to be for the next few months. So this is the U.S. Drought Monitor page. You can look that up too if you're interested. So yeah, so that's what's going on right now. And what can we expect to happen in the next few months? Well, it looks like La Nina is getting weaker. So yeah, so some places are behaving like you would expect, some aren't. But in general, we seem to be coming out of the La Nina. So if you look at the ocean temperatures, as this is for the week of June 19th to the 25th, which you can also get online from several different places. It looks like there's still a little bit of a cold anomaly in the eastern Pacific. So the blue is colder temperatures, and so here we have about a degree cooler than normal, and here we have 2 degrees warmer. So this is the typical pattern that you expect from La Nina, but it's getting weaker than it has been. So you think the end is going away. And you can see that in these model predictions. So this figure was produced by IRI, which is a research institute at Columbia in New York, and they do a lot of forecasting with a whole bunch of different models. So there's different kinds of climate models that you can use for these forecasts. There's ones that incorporate all the dynamics in the atmosphere and the ocean, and then there's ones that are based just on statistics, like you correlate things together and then you use that to predict what's going to happen. And they kind of perform about the same. It's a little depressing, because you incorporate all this complicated physics and you don't do any better at forecasting El Nino. But we use all the tools that we have available, and this is the forecast that IRA has come up with for the sea surface temperature. So again, this is this Niño 3.4 that I was talking about. And here, a value of 0 is normal, 0 anomaly, normal, and then anything above it is an El Nino. Anything below it is a La Nina. Well, you know, within about a half a degree of that is normal, but cooler temperatures is La Nina. And right now, as of April, we're in La Nina. We're coming out of that right now. But what's going to happen next is kind of all over the place. So we're going to be in neutral conditions for the next few months. Most of the models are predicting, so they're all within about a half degree. And then during this fall and winter, it's possible that we might go back into a La Nina, so we might have the same kinds of patterns that we did this winter. That tends to happen a lot with La Ninas. They weaken and then they re-intensify the next year. But maybe we could come out of it and go all the way back into an El Nino. So we won't know for the next few months. But for right now, it looks like things are kind of easing up. And if you look at the drought forecasts for the Southwest, fortunately they didn't have too much information on California, but it looks like drought conditions in the eastern plains of Colorado and in Arizona and New Mexico are likely to improve as the La Nina gets weaker. So you get that jet pattern that wants to take the precipitation further north getting weaker, so you'll get more rain as the year wears on in the Southwest. And then the rest of the country, I don't think they've done a forecast for. So, I mean, Texas is kind of going to experience more drought, they're saying, but around us, then things are likely to improve. And this is for June of September to 2011. And again, all of this is online, U.S. Seasonal Drought Outlook. In terms of the fire season outlook, for California, it's mainly normal at the moment. And this is, I don't remember exactly what months this was for. I think this is till the end of fall 2011. And the Southern California conditions, they're saying that wildfire risk is relatively normal. Possibly that's because you got more rain than would be in a typical La Nina year, so everything's wetter than it would have been. And that's only likely to stay the same or improve. And we just saw in Colorado there's going to be less drought risk, and then that is associated with less fire risk, so you have more moisture and all of that. Okay. I'm not an expert on like wildfires or anything like that, so I'll try and answer questions, but don't know too much about it. Okay, so in summary, the important points are El Nino and La Nina. They're opposites and two phases of the El Nino Southern Oscillation, which which are ultimately driven by the winds in the tropics as they interact with the ocean. So this is what's called a coupled oscillation. Very strong connections with the southwest U.S. So during El Nino, you move the jet stream further south, you get lots of rain over the southwestern states. And in La Niña, it's more unpredictable, the jet stream is further north. You get all these trough patterns happening. And generally speaking, you get more snow in the Colorado high country during La Niña winters, but in the plains you get more snow during El Nino winters. Southern California typically sees more precipitation during El Nino. Arizona and New Mexico get droughts and wildfires during La Niña. But you need to keep in mind that you can't predict these things just based on whether you're in El Nino or La Niña. You have to look at it in more detail, so every event's a little bit different. So that's most of what I had.